This is Graphing Trig Functions Part 2, brought to you by Energized Math. Please visit energizedmath.com at the end of this to download this note. When you go to Graph Trig Functions, I'm going to expand on what we did before, and we're going to do the different transformations and translations. There are four major ones, and then depending on where they are in the function as to what they do. In the A spot, it kind of affects the amplitude. The B spot will affect the period by doing a little equation of 360 divided by B. You end up dividing by what the value is right there. In the C spot, kind of in the brackets, is your phase shift, and you'll end up moving the opposite of what you see in the brackets. And the D is your principal axes. So taking a look at an example of that, here is a full trig function. It has all four different movements on there. Now, your normal trig function has an amplitude of 1, a period of 360, and principal axes of 1. Well, in this case, my amplitude will equal 2. That's what your A value is. Your period is going to be divided by the B value. So it's going to equal 360 divided by the 2, which is 180 degrees. You'll have a principal axis of 1. So it won't be centered along the 0. It'll be centered along the 1 now. So everything's going to be shifted up by a value of 1. And this x minus 90 means it's going to be shifted, and you're going to do the opposite. It's going to shift to the right 90 degrees. Okay? So the other things we can figure out is kind of like your maximum value and your minimum value. Now if it's centered on 1 and has an amplitude of 2, okay, so it's going to be centered along the 1, and it's going to go up 2 and it's going to go down 2. So it's going to go up 2 and it's going to go down 2. That means it's going to go up to 3 and it's going to go down to -1. It's kind of your maximum and minimum. So the maximum value is going to equal 3, the minimum value will equal -1. Let's try and graph this. Okay. Now I'm going to start by doing just the basic sine function, the y equals sine of x. Okay, kind of just get myself started here. Sine of x has the values of 90 and 1, 180, 0, 270, -1, 360, 0. So I graph this nice, hard to see, nice, smooth trig function. Okay? And I'm only going to use the positive angles right now to illustrate. Now I can do some things to this. Let's start by doing the amplitude, change the amplitude. So I'm going to do y equals 2 sine of x. Okay? So my amplitude is going to get doubled. So it's going to go up to 2, 0, and down to -2. And it's going to look twice as steep. Then I want to change my period now. So I want to go y equals 2 sine 2x. Now my period is going to be cut in half. All right. So it is now going to be at 180 degrees. We'll went through the full cycle. So what was at 360 will now be at 180. What was at 180 will now be at 90. What was at 90 will be at 45. What was at 270 is going to be, everything's going to be cut in half. Okay? And you'll have essentially twice the function. The function happened twice over the same 360 degree interval. Okay, now it's kind of getting a little blurry. I'm using different colors right now. Then I'm going to change my next easiest one to do would be to change the principal axes. Now I'm going to redraw it, what I have. I'm going to redraw it so I can start from scratch here. So I was going from 2 to -2. I had 360, 180, 90, 270. I had it going through 2 complete cycles. So it's going down. Okay, I did have it in red, so I might as well stick with that. And this was the equation y equals 2 sine 2x. Okay? Now we're going to do, like I said, we're going to change the principal axes, which had the +1, And so I want to move everything up 1. So it's going to go to 3 and it's going to go to -1. So everything's going to shift up 1 spot. Okay, so everything got shifted up 1. That created the function y equals 2 sine 2x plus 1. And the last thing I had to do was what the actual final answer is, and that was the y equals 2 sine 2 bracket x minus 90 degrees plus 1. Now the x minus 90 degrees, that is your phase shift. Now that's going to shift it to the right 90 degrees. So everything that was at 0 is going to be now at 90. What was here is now going to be at 90. Everything what was at 90 is now going to be at 180. Everything is going to shift over 90 degrees. And should look something like this. Okay, and then you can kind of extend it where it would be back. Alright, so that your final draft, it kind of takes a little while to get to, but it involved all 4 movements. It involved the amplitude, it involved the period being divided by the b value, it involved phase shift of 90 degrees, moving it over 90 degrees, and then moving it up. Principal axis got shifted up by 1. And so you had your final answer is this in black. And it can be a little bit messy, and that's why it's important to do it in multiple steps. Okay, this is graphing trig functions. Remember to do multiple, take your time doing it, doing multiple steps, and each thing involved one different movement to do. Okay, you had your amplitude, you divided your period by the 2 value, or the b value. You had your phase shift, do kind of the opposite of what you see in the brackets, and then you had your principal axes of shifting it up 1. Thank you very much. This was brought to you by Energize Math. Please visit energizemath.com to download this note. Thank you.